Alright, question 1. Read the proof below carefully, then fill in each blank with the best answer. Given that ABCD is a parallelogram, prove that any two consecutive angles of ABCD are supplementary. Alright, the first thing I'm going to do is I'm going to duplicate the tab. And I'm going to scan for a proof that's similar to this to see if I can use it to bounce off ideas. So I'm just going to look to see if we can prove consecutive supplementary angles. And I'm going to keep scan. Right here it says here's the theorem, and then here's our proving the theorems. So I'm noticing that this one on angle D and angle A, they're hitting this same line AD, which is going to be our transversal, because here's our parallel lines right here. So notice again on the transversal, there's the left side of the transversal, here's the right side. They're both on the right side, so they're same side. Are they in between the lines? Yes. So they're same side interior angles, so same side interior. So that is what right here goes. So I'm noticing right here it says the blank goes right here, so same side interior angles. You can state that the angles are supplementary from that. So I'm just using the information given in the statement. It says angle D and angle A are supplementary angles. If you filled in this blank with what this is, it says same side interior angles theorem. So that's really helpful to know. So there's our reference, and here's our proof. Another thing that you could do is if you do not have a list of all of the theorems, click on the announcements tab, click on the website resources, and notice that right here it says this is a list of postulate theorems and properties from geometry A. So this ends at HTML. And I'm just going to copy it and paste it here. And if you wanted to, you could scan until you saw same side interior angles theorem, which is right here. And this just has a list of all of the theorems if you wanted to use that as a resource when it's asking you about specific theorems. Here it is. So those are the two options we can have. And just notice that it does say the same thing. If two parallel lines are cut by a transversal, then same side interior angles are supplementary. So that's exactly what happened in this example right here when we filled in our blank with same side interior. It said that they were supplementary because of the same side interior angles. So let's use that knowledge and help us with this one. I'm going to jump right here and see if we can make sense. We may have to go to the statement 2 beforehand. So it says, likewise, segment BC is a transversal of parallel line segment AB and segment CD. So angle B and angle blank are same side interior angles along parallel line segments. Okay, so it's identifying segment BC as the transversal, and it's identifying segment AB and segment CD as the parallel lines. So again, here's the left-hand side of the transversal, here's the right-hand side. It's saying so that angle B right here and angle blank are same side interior angles. Okay, well, it just gave us what they were, same side interior angles. So they have to be on the left-hand side and they have to both be between this parallel line. That means it has to be angle C. So on this, yeah, it's C, comma, space, and therefore applying the same side interior angles theorem, it is possible to conclude that angle A is blank to angle D. Well, okay, in this blank it said same side interior angles theorem. The angles were supplementary. If we went to our list of postulates, if two parallel lines are cut by a transversal, then same side interior angles are supplementary. So it's possible to conclude that angle A is supplementary to angle D. So supplementary, comma, space. That goes there, there, and there. So now we want to look at this for the blank 3. And it's saying, using the same line of reasoning, but instead consider that segment AD is parallel to segment blank, and these parallel lines are cut by transversal segment CD and segment AB. Alright, so now we're flipping it. Instead of looking at the top and the bottom pair of parallel lines on the parallelogram, they're asking us to look at the left-hand side and the right-hand side as parallel lines, and these as transversals. So this would be the left-hand side of the transversal, and this would be the right-hand side of the transversal. So when I'm recording this, I'm literally tilting my head to the left so I can kind of orient it more upwards. So if tilting your head helps you see that better, see that the transversal runs this way and that these are the parallel lines, please do that. So segment AD is parallel to segment, well, it's segment CB because that's its opposite side right there. So that's how we would use our example proof and the list of postulates to answer this question.